Chapter 2, Example 1. Medical researchers followed 6,272 Swedish men for 30 years to see if there was an association between the amount of fish in their diet and prostate cancer. Their results are summarized in the table shown. Is there an association between fish consumption and prostate cancer? So it's difficult to tell from the table because there were different amounts of no and yeses, different amounts of people that had seldom than from a small part of a diet. So it's hard to see. We want to look at some breakdowns here, some percentages. We're going to start by looking at a marginal distribution, which is where we take the totals of everything. So we find out how many total people were involved in the survey. How many total people said no? How many yes? How many total people never or seldom ate fish, and so on. So we fill out the margins around it. And it's important to understand a marginal distribution versus a conditional that we will get to in a few minutes. So marginal distribution is out of the whole. In this one, the marginal distributions won't be as helpful, so we want to look conditional probabilities based on a condition here. So what I want to say is I want to look at, out of all those that did not develop cancer, what percentage of them had fish as a small part? What percent had no part of their diet? What has a large part? So we'll look at those 5,806 people that did not develop prostate cancer. Let's look at never or seldom ate fish first. So 110 of those never or seldom ate fish. So we're going to have 110 over 5,806, which gives us a probability of 0.0189. Now, probability is always a number between 0 and 1. If we wanted the percentage, we would multiply by 100 and it would give you about 2%. We also want to look at, of those that developed cancer, what percentage of them never or seldom ate fish. So that would be 14 that never or seldom ate fish and developed cancer. And on the bottom we have 466 that did develop prostate cancer. So that gives us a percentage of 0.0343. which is a little higher than of not having cancer. We'll do this for the next row as well, small part of the diet. So small part we have 2,420 over 5,806, which gives us 0.4168. For yes, they develop prostate cancer, it's 201 over 466, which is 0.4313. And then we repeat that for moderate part and large part. We just go through the same calculations. We now have a conditional frequency distribution. You can see for those that did not develop cancer, we had a 0.0189, never or seldom ate fish, so I multiplied by that 100 and got a percentage. And for no's, we have 1.9, 41.7, 47.7, 8.7. That adds up to be 100. And it should be, because I'm looking just out of that column what percentage never or seldom ate fish. What percentage had it a small part of their diet. For the yes, the same thing. Those will total up to 100%. Because I'm saying, out of those that did develop prostate cancer, what percentage never or seldom ate fish? What percentage had it as a small part of their diet? Above, we had a frequency distribution because they are the counts. Our table below is a relative conditional frequency distribution. So now that we have that information, let's put it in a graphic and help us see things. For categorical data, there are two charts that we generally use, bar graphs and pie charts. We're going to do a pie chart here and see if we can see what slice of this. If you were doing this by hand, you could get a protractor and say, small part of the diet was about 42%, so I need to find how many degrees that is out of 360 and sketch that out. We're using technology here which does it pretty easily for us though. Moderate part's going to be in green, large part in purple, and then we have no or seldom in red. That was for no prostate cancer. So now we want to look at developing prostate cancer and see if there's a significant difference. So prostate cancer, small part of diet is in blue. It looks about the same size. Green, again, looks about the same size. Purple looks about the same size. One of these has to be a little bit smaller because that red looks a little bit bigger, but not a whole bunch. So from this pie chart, they look pretty similar. The reds may be a little bit bigger, but the graphs in general look pretty similar. So it's not really answer our question. It's not enough of a difference here to prove anything to us. So let's look at this in a different way. Here we have our marginal distribution again. I'm going to look at conditional probabilities based on the rows instead of the column. So out of those that never or seldom ate fish, what percentage developed prostate cancer? Which percentage did not? Out of those that had fish as a small part of their diet, what percentage did develop prostate cancer and did not? So we're starting with never or seldom and developing prostate cancer. There were 124 people that never or seldom ate fish. 14 of those 124 did develop prostate cancer. So 114 over 124 gives us 0.113. So this is just another conditional probability. We're just stating a different condition. Let's do small part of the diet. So there were 2,621 people that had fish as a small part of their diet. Of those 2,621, 201 developed prostate cancer. So we have 201 over 2621, which gives us 0.077. And we'll continue this going down the chart. I'm not going to show all those calculations. You can do this pretty easily now. But now we're going to do a bar graph. Now this bar graph won't go to 100% because these aren't going to add up to be 100% because of the way we did our table here. Now, never or seldom, if I did no prostate cancer, yes prostate cancer, would go to 100%. But I'm showing all of them having a condition of type of fish. Okay, so never seldom was 0.113, which is about 11.3%. So we just make a bar up to 11.3. Again, technology makes it really easy. If you're doing it by hand, I'd recommend using some graph paper. For a small part of diet, we calculated that already, it's 0.0771. And moderate part and large part turned out to be very similar. About 7 for moderate part and about 7.8% for a large part. Now this graph helps us to see more clearly. It looks like the chance of cancer by fish consumption was higher if you never or seldom ate fish. However, the amount of fish that was consumed did not seem to impact the cancer rate. As long as you had some amount of fish, it doesn't seem to matter how much. So now we'll write this up. There does appear to be an association between eating fish and the chance of getting cancer, though the amount of fish consumed does not seem to matter. 11.4% of those that rarely or never eat fish developed prostate cancer, while only around 7% to 8% of those that ate any amount of fish developed prostate cancer.